Chemical bonding. The Lewis theory of bonding. The key ideas of the Lewis theory of bonding are: atoms and ions are stable if they have a noble gas-like electron structure, i.e., a stable octet of electrons. Electrons are most stable when they are paired. Atoms form chemical bonds to achieve a stable octet of electrons. A stable octet may be achieved by an exchange of electrons between a metal and a non-metal. This would be an ionic bond. Or a stable octet of electrons may be achieved by the sharing of electrons between non-metal atoms. The sharing of electrons in this manner is a covalent bond. So what are the properties then of an ionic solid? What is an ionic solid? Ionic solids are solids composed of oppositely charged ions. They consist of positively charged cations and negatively charged anions. These solids are held together by electrostatic forces, plus and minus attract. They have high melting points. They are crystalline with smooth, shiny surfaces. They are hard but brittle, and they're non-conductors of electricity and heat. What is lattice energy and ionic bonding? The amount of energy given off when an ionic crystal forms from the gaseous ions of its elements is called the lattice energy. Bond energy. Bond energy is the energy required to break the force of attraction between two atoms in a bond and to separate them. Bond energy is therefore a measure of the strength of a bond. Predicting ionic and covalent bonds. Properties of a covalent molecular compound. These exist as a soft solid, a liquid, or a gas at room temperature. They have low melting points and boiling points. They are poor conductors of electricity, even in solutions. May not be soluble in water. Acetone, however, is one of the many exceptions. This chart will help you determine the type of bonding likely to occur. What you need to know is the formula of the compound, and this will help you to classify it. Use electronegativities. A polar covalent bond is a bond that's covalent, but it has an unequally shared pair of electrons between the atoms. This unequal sharing results in a bond that has partially positive and partially negative poles. Metallic bonding. About 2/3 of all the naturally occurring elements are metals. The properties of metals: they conduct electricity, they heat in both their solid and liquid states. Most metals are malleable and ductile, easily stretched, bent, and deformed without shattering. And they show a broad range of melting and boiling points. Most metals have either one or two valence electrons. Electron sharing in metals occurs throughout the entire structure of the metal. Free electrons continue to bind the metal ions together. The force of attraction between the positively charged cations and the pool of valence electrons that moves among them constitutes a metallic bond. Properties explained by the free electron model. Conductivity. Metals are good conductors of electricity and heat because their electrons can move freely throughout the metallic structure. Malleable and ductility. The malleability of metals can be explained by viewing metallic bonds as being non-directional. Melting and boiling points of group 1, the 1A metals, are generally lower than the melting and boiling points of group 2. This is because of the greater number of valence electrons. And here is an example of what the shapes could look like.